Hey there, Charles here, and welcome to another Unity tutorial. In today's video, we're going to take a look at how to add automated tests to existing Unity code. For our example, we're going to use some code I've been writing for an isometric survival game I've been working on. I had a need for an enemy spawner that spawns enemies from a prefab in a circle around the player with a configurable radius and a configurable spawn rate. In order to visualize this, let's set the spawn rate to 0 so that a new enemy is spawned on each frame, and the radius to 10 so that the enemies are spawned within the viewport. And we can also replace the enemy with a cube so that it'll be easier to visualize the end result. As we can see, the cubes are spawned in a random location on the boundary of a circle with a radius of 10. Now that everything is working, we can take a look at the code. At first glance, you might notice that this code looks pretty prototypical, in the sense that I don't do any error checking. I've given my variables okay names, but I don't go to any great lengths to make this human readable, and plus I've dumped everything into this update method. Still, it works for our purpose, so let's just take a look at what it does. The first thing you'll notice is that I instantiate a new random if random is null. Again, very prototypical. I would never do this in production code. The next thing I do is check to see if time since last update is greater than or equal to our spawn rate, in which case I could spawn a new enemy, which I do using the Prefab utility and our enemy prefab that was set on the class. The next thing I have to do is calculate a random position on the boundary of a circle with our given radius. I do this by finding a number between 0 and 361 to represent our degrees, our random degrees. The next thing I do is calculate x and y using cosine and sine, and multiplying those values by the radius. Also, due to float imprecision, I have to round very low numbers to 0. Just a small detail of what I'm doing. Once I have my x and y, I set the enemy's position with a new vector. Lastly, I set time since last spawn to 0, and I increment time since last spawn by time.delta. So now that we know what the code does, I'd like to expand on this code. I'd like to add waves of enemies, or even different types of enemies based on the difficulty selected by the player. But adding to this code could potentially break it. How do I know if my additions and my refactorings are breaking anything? Well, I could switch over to the editor and press play and make sure that things are going the way I expect every time I make a change, but why not let the computer handle it? Well, that's where automated tests come in. We're going to identify the main functionality of this script and then create automated tests to ensure that no matter what we do, we don't break that functionality moving forward. To get started, let's create a script that will hold all of our tests. We're going to create a play mode test because we'll need to be in an environment where Unity's update and start methods are called. Now that we have our test script in place, we can go ahead and start writing some tests. But where do we begin? Well, the thing that pops out to me at first is the whole instantiating enemies from a prefab. It seems to me to be pretty important that the enemy spawner use the prefab that we've set to create new enemies. So I think that's a pretty solid place to start. We'll create a Unity test, which is the type of test that calls Unity events on the mono behaviors under test. And these sort of tests expect an IEnumerator to be returned because they're treated like coroutines. And we'll call our test instantiate game object from prefab. When we check this out in the test runner, it should be pretty obvious what it's doing and what it's testing, especially if it fails. We want to be able to tell right at a glance what went wrong and where to start looking. Now that we know what we're going to test, we can get started. One popular way to write unit tests is to start with the assertion. Asserts are conditions that must be true in order for the test to pass. In our case, we're going to have some enemy prefab, and we want to make sure that it is equal to the prefab of the spawned enemy. Working backwards, we're going to have to figure out what the prefab of the spawned enemy is. To that end, we're going to use the Prefab utility class. It has a couple of helper functions that make dealing with Unity's prefabs a little bit easier. Into this, we're going to pass the spawned enemy. This will return the prefab that the spawned enemy uses, and we'll use it for our assert. Because this is tagged as a Unity test, I'll be able to query the scene for game objects. I'm going to find our spawned enemy by searching for game objects with the tag enemy. Now that we've got the right side of this assert completed, we're going to need to create an enemy spawner. Now, for each one of these tests, the enemy spawner is going to have a different state in order for us to test the different functionalities. The problem is, the three variables that pretty much make up the state we need to adjust are private. They're serialized fields and they're expected to be changed in the editor, but of course for a test we can't do that. One thing I like to do, something I picked up from using Ninject, is to just expose variables like this via a construct method. It's kind of like having a constructor. And while we're here, this is kind of bugging me, so I'm going to rename this enemy prefab to fit the convention of underscores that I've been using. And I should probably fix this typo. Spawner. Okay, so the construct method will allow us to set up the state of the enemy spawner for this test. So I'm going to pass in the enemy prefab, which we'll define next. I'm going to do a spawn rate of 0 because I'm only going to allow one update to pass, and I need to make sure the spawn happens. And the radius doesn't matter, so I'm going to set it to 1. For our enemy prefab, I'm going to go ahead and just load it from the resources folder. I'm going to have to create this tests folder, and I'm going to put an enemy prefab in it. Now, this isn't ideal. Later, when I refactor the enemy spawner, I might have some sort of enemy prefab service, something that I could mock so I don't actually have to load files from the system. But for now, I'm going to leave it in with the knowledge that I'm going to update it later. Now, you may be wondering, when does the update get called? Well, with Unity tests, you actually need to pass back an IEnumerator. So in our case, we could actually do something like return new wait for seconds 5, and this test would literally run for 5 seconds. But since we only need a single update to pass, we'll just return null. And this will be enough to have our Unity environment call one update before it comes into this assert and checks the state of the system. We're almost done, but in order for our test to work, I need to create that resources folder. It was under resources, and then another folder called tests. And I'll create an empty prefab. We'll call it enemy, and I'm going to assign it an enemy tag. Remember, this enemy tag is what we used in the test to find the enemy in the scene. I'll create a prefab out of it, and we should be good to go. Now our tests have compiled, and we can see them here in the test runner. Instantiates game object from prefab. But before we run it, let's do a little bit of an overview. So first, we load an enemy prefab, the one that we've tagged as enemy, into this enemy prefab variable. Then we create a new spawner by creating a new object and adding the component enemy spawner. Then we construct our enemy spawner, setting its state by passing in the enemy prefab, 0 for the spawn rate, and 1 for the radius. Remember, 1 doesn't really affect us in this case for the radius. Then we yield return null. This will cause the update method to be triggered on the enemy spawner. Once that's done, we expect that there will now be a spawned enemy within our scene that we could find by the tag enemy. We search for it, store it in the enemy spawner. Then, using the prefab utility, we get the prefab parent of the spawned enemy and store it in this prefab of the spawned enemy. Now, at this point, we expect that this prefab of the spawned enemy should be equal to the enemy prefab that we passed into the enemy spawner, and we use this in our assert. If this is true, then our test will pass and everything will come up as green. Well, cross your fingers. Alright, but don't celebrate too early because we still got 2 more tests to write. They should be a little simpler though because we have our enemy prefab set up and we already know how we're going to find it by its tag. But first, we need to take care of a little side effect that happens with these Unity tests. Because Unity tests run in active scenes, you have to take care of the game objects that are made during each test, or else they might affect the outcomes of other tests. So, after every test, I'm going to loop through all the game objects that have the enemy tag, and I'm going to loop through all the game objects that are of type enemy spawner, and I'm just going to delete them from the scene. There, now we don't have to worry about the test stepping on each other's toes, and we can move on with the next test. Just an FYI before we move on, the teardown attribute is part of the NUnit library. Basically, any method marked with teardown will be run after every test. Alright, so for our next test, we need to pick another bit of functionality. So apart from instantiating game objects from the prefab, our enemy spawner instantiates game objects at a random position on the boundary of a circle. So I think that's a pretty good place to go to next. So we'll create another Unity test. Returns an enumerator. And we'll say instantiates game object at random position on circle boundary. Alright, cool. So just like before, we're going to start with the assertion first. In this case, we're going to have to assert against two positions. Some expected position and our spawned enemy dot transform dot position. So to get our spawned enemy, that's pretty easy. We can use the exact same method we used above, which is to query it with the tag. Now to find our expected position, I'm going to use a unit circle for reference. If I set my radius of my enemy spawner to 1, then I could just say for 270 degrees I'll expect 0, -1 as my coordinates. And that's what I'm going to do. We're going to use 270 degrees. So I'm going to say new vector 3, 0, 0, and the way that the coordinates work in Unity, that y coordinate is going to fall here in the z, so that -1 is going to be in the z coordinate. So I'm going to complete this test by committing a cardinal sin as a developer, and that's by copying and pasting some code. Now we're almost done with this test, except for one thing. This expected position is based off of 270 degrees. The problem is, enemy spawner gets its degree calculation from random. So in order to ensure that it uses 270 degrees for our test, we're going to need to mock random and pass it in. So in order to pass it in, we're going to replace this private variable with an auto property, with a public setter. So we'll do that here. Then we'll go over to our test and we'll mock up an instance of random. For this I'm using nsubstitute. It's a great mocking framework. It used to come with the Unity test tools. Now you just have to import it yourself. So we're going to substitute random, and I'm going to make sure to use system.random because Unity has its own random class that has a different API. So we're going to say when random.next is called with any int for both of its arguments, with any int, that it's going to return to 270. So when you look at the enemy spawner, when this is called, no matter what's passed in this case it's 0 and 361, 270 is what the return value is going to be. Then once that's done, we can set it up by saying enemy spawner.random equals random. Now our test is ready to go, and we should be able to run it and get our results. Alright, so we'll switch on over to Unity and let it build the test. Alright, the test is built, and we'll give it a run. And alright, it passed. Everything is good. Now we can move on to our next test. So we'll be testing our last bit of functionality, which is that the instantiations occur on an interval. And that interval, of course, is based on the spawn rate property. So instantiations occur on an interval. Now this test is a little more straightforward in that we don't have a lot of setup, but it's going to be a different assert. And what we're going to assert is that when we search the scene for an enemy, that enemy doesn't exist. We're going to change the spawn rate from 0, which is what we've been using in our previous test, to 1. And instead of yielding a return to null, we're going to yield a return to a new wait for seconds, and we'll do something below 1 second. So we'll just say 0.75 seconds. It's a float. And of course we have to search for our spawned enemy. So based on the fact that we're going to set up an enemy spawner with a spawn rate of 1, assuming that less than a second has elapsed, there should be no enemy in the scene. So we'll do our setup like we did before, except this time we're going to set that spawn rate to 1. Alright, so because enemies spawn every 1 second, this will be null. Like I said, pretty straightforward. We'll let Unity build the test, run it, and there you go. There was no enemy in the scene at this time. So as far as I'm concerned, we may have missed 1 or 2 little gotchas or conditions that we could have tested against, but I think that just to get us started in refactoring this script, I feel pretty confident with just these 3 broad tests that we've written. Now, some might argue that these are more integration type tests, and in a way they are, because they really do depend on the Unity subsystem working as we expect. You've got 2 separate systems working together. And, you know, we could split hairs, but for the sake of this class under test, I'm going to feel pretty confident in calling these unit tests because I'm just testing this one unit of work, this update method. Now, as we split up this class, we're going to see that the units will appear to be more lower level, more very solid focused methods. But for now, these integration / unit tests, these make me feel confident in moving forward. So how can we move forward with this? Well, I mentioned before that I didn't go to any great lengths to make this update method human readable. So I think we can kill 2 birds with 1 stone by making it a little more readable while removing some of the duplication as well. So let's start with this x coordinate. I think using refactoring, Resharper's refactor, I can extract method and call it something like get or calculate x coordinate given these degrees. So let's take a look at that. That looks fine. Now with every refactoring, you should rerun your tests just to make sure that they're still passing. So we'll do that. Alright, that refactoring didn't break anything, so we can continue and do the same thing with y. So we'll call it something similar, calculate y coordinate. And I think that looks pretty good. Again, we can rerun our tests. Make sure that everything's still kosher. Great, and for our last little bit of refactoring, I think I want to inline these variables. Do that. And so now we're getting our x coordinates given these calculated x and y, our vector given these calculated x and y's. But I think I can go actually a step further. And I could highlight this and do another refactoring. Could extract this once more, and we'll say get position on boundary of circle. Alright, probably come up with a better name, but that works. And now, all of a sudden, with these 3 little extractions, our update method looks a lot leaner and a lot easier to read. In fact, I can inline this and make it a little bit more leaner. So what do we do here? We create an enemy from the prefab, then we set its transform.position to a position on the boundary of a circle, and that's it. Pretty nice. So the first thing that pops out to me is that these 3 extracted methods really have nothing to do with the enemy spawner. It uses degrees and the radius, but it doesn't use enemy prefab or spawn rate. These all seem to pertain to something like a circle. So I think this is a great opportunity to extract a class. So we're going to use Resharper's extract class function. We're going to call this class circle. And I'm going to need access to a radius and our 3 methods that we extracted before. And we'll make the get position on boundary of circle public. Alright, so we'll extract that into its own file. Now we're going to have to do some refactorings by hand, like removing the serialized field because this isn't a mono behavior, but Before we move on, we're going to rerun our test to make sure that everything passed. Another thing we have to look at is how the circle gets instantiated on enemy spawner. All of our tests passed, so we can move on forward. One thing that's important to note is that our radius property got removed, so we're going to re-add it here. We still need to be able to manipulate this class via the editor. So I'm going to change a couple things, and the first thing I want to change is I want to add a constructor to circle that accepts a radius. Also, I'll remove this serialized field. Okay, and in the enemy spawner, I'm going to change the way that this is instantiated. And I'm going to remove this read-only property. So now, this will have to get instantiated in two places. First, in our constructor, so we'll say circle equals new circle, and we're going to pass in our radius. Also, we're going to kind of do a little bit of a hacky thing here. We're going to say if circle is null, we'll say circle equals new circle, and it's going to use the radius that was set on the editor. There are better ways to handle this, but for the sake of getting this done quickly, we're going to leave it like this for now. And the great thing about tests is that we'll just be able to refactor it later and make sure that nothing was broken. In fact, I'm going to do that now. We'll rerun our tests and make sure that these changes didn't break anything. And the next thing we'll do is remove that property on circle that's no longer needed. So our test passed. Now we can get rid of this. And we can make this read-only for now until we need to change it later. And great. So what we're left with as a result of our refactorings are two very lean classes, both under 40 lines of code. We've got our enemy spawner down to, well, 41 lines of code here. We've got a really nice looking enemy spawner. We're going to need a better way to set these properties, of course, but for now, as far as adding the functionality that we want, like adding waves and increased difficulty in the form of different prefabs for the enemies, we've got a nice base to work with. We've got a class that's being tested, and we've got a class that's pretty lean, so it's no longer as intimidating to add new code to this, whereas before, adding new code, it's just like adding so much more onto this huge class that eventually becomes this giant monolithic thing. So I'm pretty happy with this. And before we finish this video, I think we should pop on over to the editor and see it in action one more time. So if you recall from before, we had set our spawn rate to 0 and a radius of 10 with our cubes. So we'll press play and make sure that's still working. Great. And now, for a little bit of fun, we can crank up that radius to 3, maybe change our spawn rate to 1, and replace our cube with our enemy prefab that'll come and try to attack us. Alright, so we've got some enemies spawning. It seems pretty good. They seem to be coming from random positions on a circle or in a radius around me. Well, they're coming in pretty quick. I might need to tune this game. It's a little out of balance. Getting my butt kicked here. And that's it. Well, thank you guys for watching. If you have any comments or critiques or suggestions, please leave them in the comments below. And like, subscribe, and keep checking me out. I appreciate all your feedback as of late, and I'll be continuing to make videos twice a week. Thanks so much, guys.